Have you ever wondered what's behind the incredible power of a jet engine and how it manages to propel a massive plane through the air? Maybe you've sat at a window seat, felt the rumble beneath you, and marveled at the sheer force that's pushing you forward at hundreds of miles per hour. It's an amazing feat of engineering. And yet, for most of us, the jet engine remains a bit of a mystery. We know it's powerful, we know it's complex, but how exactly does it work? Is it like a giant fan, blowing air backwards to move the plane forward? Or is it something more intricate, involving combustion and clever design? The truth is, a jet engine is actually a remarkable piece of machinery, and understanding how it works can be pretty fascinating. So, let's take a closer look and find out what makes these incredible engines tick. By the end of this, you'll have a clear understanding of the basics and a new appreciation for the technology that gets you safely from one place to another. And who knows, you might just find yourself marveling at the jet engine in a whole new way. Vocabulary: turbine, propulsion, combustion, efficiency. So, have you ever blown up a balloon, tied it off, and then let it fly across the room by releasing the air? That's basically the principle behind how a jet engine works. It all starts with a fundamental idea. Jet engines work by expelling hot gas out of the back, which creates a forward thrust. This is based on Newton's third law of motion, which says that every action has an equal and opposite reaction. In the case of the balloon, the rushing air exiting the balloon is the action, and the balloon flying forward is the reaction. Jet engines use the same idea, but instead of air from a balloon, they use hot gas produced by burning fuel. And here's the surprising part. This hot gas is incredibly hot, so hot that it can melt metal. But by carefully controlling the flow of this gas, jet engines can produce a tremendous amount of thrust, enough to power a massive airplane through the sky. The key is to understand that it's not the gas itself that's moving the plane, but the speed and direction at which it's being expelled. And that's what we'll explore next, how this hot gas is produced and controlled. So, how does a jet engine actually take in air and turn into thrust? It all starts with four main components that work together like a well-oiled machine. Imagine a factory production line, where each stage builds on the last to create the final product. In this case, a high-speed jet of gas that propels the plane forward. The first stage is the compressor, which sucks in huge amounts of air, kind of like a giant vacuum cleaner. This air is then passed into the combustion chamber, where fuel is added and ignited, producing a hot, high-pressure gas. And here's the part most people don't know. This gas is incredibly hot, so hot that it could melt the engine itself if it weren't for the clever design of the next stage, the turbine. The turbine extracts energy from the hot gas, using it to power the compressor and other engine components. Finally, the gas is accelerated out of the back of the engine through the nozzle, which is designed to maximize the speed of the gas, producing a high-velocity jet that generates the thrust to propel the plane forward. So, to answer the question, a jet engine works by using these four main components: compressor, combustion chamber, turbine, and nozzle, to create a high-speed jet of gas that produces thrust, and that's what we'll be exploring in more detail next. Vocabulary: compressor, combustion, turbine, nozzle. What if I told you that the fuel you think is powering the plane is actually just a small part of the story? You see, when we talk about jet engines, we often focus on the fuel they burn, but that's not where most of the energy comes from. And here's the surprising part. Most of the energy produced by the engine doesn't actually come from the fuel itself, but from the oxygen in the air. Think of it like a fire. You need fuel to get it started, but once it's burning, it's the oxygen that keeps it going. In a jet engine, the fuel just acts as a catalyst to release the energy stored in the oxygen, making the process incredibly efficient. It's like a tiny explosion happening inside the engine, where the fuel ignites the oxygen, and that's what produces the thrust. This is why jet engines can be so powerful, because they're not just burning fuel, they're harnessing the energy of the air itself. And that's what makes them so remarkable. So, to answer your question, the energy that powers a jet engine doesn't just come from the fuel, but from the air it breathes, making it an incredibly efficient and powerful machine. Want to know how this energy is then converted into thrust? Vocabulary: catalyst, efficient oxygen thrust. So, what happens when you combine a compressor, a combustion chamber, and a turbine, and then add in the principles of energy conversion and thrust production? You get a jet engine that can produce tens of thousands of pounds of thrust, which is what propels a plane forward. To put that in perspective, imagine a large building with a massive fan on the roof, blowing air downward with such force that it could lift the entire building off the ground. That's roughly the amount of thrust a jet engine can produce. And here's the surprising part. Despite the incredible forces at play, jet engines are also incredibly reliable and safe. They have to be because they're responsible for getting hundreds of people safely from one place to another. The reliability of jet engines is due in part to the simplicity of their design, as well as the rigorous testing and maintenance they undergo. This is why flying is still one of the safest modes of transportation, with accident rates being incredibly rare. So, the next time you're on a plane, you can feel reassured knowing that the engines powering your flight are both powerful and reliable. And that's what makes air travel so remarkably safe. Vocabulary: turbine, combustion, propulsion, reliability. So, to answer the question, a jet engine works by using a combination of air, fuel, and clever design to produce a massive amount of thrust. Here's how it all comes together. First, the engine sucks in lots of air through its intake. Imagine you're standing next to a really powerful fan. That's kind of what the engine does, but way more efficiently. This air enters the compressor section, which is like a series of spinning blades. These blades spin incredibly fast and squeeze the air into a tiny space, making it super dense. Next, fuel is injected into this compressed air. It's like adding a little bit of kerosene to your fan setup. The air and fuel mix together in the combustion chamber. Then, just like when you quickly open the valve on an aerosol can, that mixture gets ignited with an initial spark. The flames burn super fast, expanding the gases and pushing them out the back of the engine at incredibly high speeds. This push works exactly backward to the direction of travel. According to Newton's third law, for every action, there is an equal and opposite reaction. So, as these hot gases are pushed out, they create a tremendous amount of thrust, pulling the plane forward with them. And here's the surprising part. It doesn't matter how much air you pull in or how much fuel you burn. What really counts is the speed at which that exhaust comes out. That's why even small jet engines can generate incredible power and get planes moving fast. If you're curious to learn more about how flying really works, be sure to subscribe for more explanations and insights into the fascinating world of aviation. Whether it's the mechanics of a wing or the mysteries of air traffic control, there's always something mind-blowing to discover.